In this video, we are going to take a very quick look at our third and final form of our quadratic functions, which is, of course, factored form. It's also called intercept form, and the reason it's called intercept form is because it gives us our x-intercept, which is always nice. It gives us our x-intercept. So here is the form. It is a times x minus p times x minus q. So hopefully you can look and see why it's called factored form. The polynomial is factored. And what it gives us is our x-intercepts. So let's talk about a couple of key features here, or a couple of key important things, important notes. The value of a is the same as the a from standard form, ax squared plus bx plus c, and vertex form, a times x minus h squared plus k. So the a is the same, still determines how it opens, still determines all of our other stuff that we need to know, okay? The x-intercepts of the graph are given from p and q. Notice that minus thing that's happening, p comma 0, q comma 0. So it's like the x minus h. You're going to take the opposite of what's in there, and we'll look at some examples in just a minute. And then our third and final statement here, the zeros of the function are x equals p and q. So zeros are values of x that make the function equal to 0. They correspond to the x-intercepts of the graph. So we're going to put a couple of things together here. The first thing that we're going to talk about is going from standard form to factored form. So we're going to do two examples. Go ahead and write your instructions. For each example, rewrite the quadratic function in factored form. And here is our example 1. So I want you to go ahead and write down example 1. And here's how we go from standard form to factored form. We factor it. So this one is a nice simple one with the leading coefficient of 1. So I'm going to multiply a times c. So I want to multiply to 15, and I want to add to negative 8. So it's going to be 1 and 15 doesn't work, 2 doesn't go. How about 3 and 5? Both of them negative. Since it's a shortcut method, I know I can go straight to here. I don't have to do the whole box. And my two numbers I'm going to use are negative 3 and negative 5. I am now in factored form. If I wanted to identify my a, p, and q, because we're in factored form, so a, p, and q are the values I would look for. My a is 1. My p is 3. Oops, I almost did negative 3, but it's x minus p, so it's a positive 3. And my q is 5. And that is factored form when it's nice and simple, when that leading coefficient is 1. Pause if you need to. I'm going to go on to example 2. And here is example 2. Write it down. And again, we're going to factored form. So you know what we're going to do? We're going to factor it. But ooh, be careful here. We have two things going on. First of all, notice that that right there is negative. Anytime your leading coefficient is negative, you want to pull out a negative. The other thing I want you to notice here is that all of my terms are even. So I am going to start by pulling out my GCF. My GCF here is negative 2, and I am going to start by pulling out that negative 2. So I'm going to divide all of my terms by negative 2. So negative 2x squared divided by negative 2 is a positive x squared. 12x divided by negative 2 is a negative 6x. 14 divided by negative 2 is negative 7. So I pulled out my GCF to start. You are always going to want to do that first. Always, always, always. Then I am going to factor what's left. Again, my leading coefficient here is 1, so I know I've got this shortcut method. I am going to multiply to negative 7 and add to negative 6. So 1 and 7 with the 7 being negative. So plus 1 minus 7. And again, if I pick out my A, P, and Q, my A is that number in front. It was my GCF that I pulled out. My P, it's X minus P. So this X plus 1, you're going to think of as an X minus a negative 1. So P is negative 1, and Q is 7. So what this tells us, the A being negative 2 tells us this thing opens down and is narrow. The P being negative 1, we have a 0 at negative 1. The Q being 7, we have a 0 at 7. That's what that tells us. Again, pause if you need to. The next thing that we're going to look at is writing an equation from the graph. Won't that be fun? So let's go ahead and write our instructions. For each example, determine the equation of the function in factored form. So this time I'm going to have a graph. So here's example 3. And I realized I did that kind of fast. So finish writing your instructions. So when you look back, you know what you're looking at. And then here's example 3. I do want you to draw the graph. And what I've done is given you kind of 3 points to go by. So the 3 points for the graph that you're going to use, these two right here are our zeros. And then this one is my vertex. My vertex isn't important to me to write the equation, but it will let me at least see where everything is, how to graph my equation. So I can tell from this, my P is going to be negative 1 and my Q is going to be 3. Because those are my zeros. So I'm getting that from here and here. It doesn't matter which one's which. It can be either way. The A is a little bit more complicated, and this is one reason why I need to know my vertex. Remember, to find the A, we go step to the right and count up. So since I counted up 1, my A here is 1. So this is how I find my A. So to write my equation, it's going to be A times X minus P. So minus, I'm going to write it and then I'll simplify it, a negative 1 and X minus Q. So it's going to be 1 times X plus 1 times X minus 3. We're going to do one more example like this. Pause here if you need to. I know the video is getting a little long, but we want to look at least one more. Okay, example 4. Again, I want you to go ahead and plot 3 points. I want you to plot your vertex, I'm sorry, your zeros, your x-intercepts, and I want you to plot your vertex. And again, my zeros are super easy. In factored form, what I need is A, P, and Q. So my P is negative 3, my Q is a positive 1. My A, step to the right and count. I went down 2. So my A is negative 2. So my equation here, I know my A has to be negative because it's opening down. And then I'm going to go X minus a negative 3, so plus 3, X minus 1. And that is it in in factored form, or we also can call it intercept form.